Hi, I'm Mathis, and I'm going to present our work, TEMOS, generating diverse human motions from textual descriptions. Given a sentence in English, such as a human walking in a circle clockwise, our goal is to synthesize diverse and realistic motion sequences that match the text. As you can see below, all the three generations correspond to the text, but they are different motions. Besides the skeleton representation, our proposed framework is also compatible with the skin simple body model. Previous work in text condition motion generation includes Language to Pose and the work of Gauche et al. They both use an autoregressive decoder in a deterministic fashion, together with complex training strategies. In our work, we simplify both the architecture and the training, while probabilistically generating multiple plausible motions with a non-autoregressive architecture. Here's how our proposed model TEMOS works. Starting from a text sequence, we use a Distilbert pre-trained language model to extract text features. Then, after going through a transformer encoder network with extra learnable parameters, we obtain the Gaussian distribution parameters mu and sigma, from which we can sample a latent vector ztext. This latent vector is then fed into the motion decoder to produce a motion in a non-autoregressive manner. This was TEMOS during test time. As in prior work, we are using a motion encoder and define a reconstruction loss both on the text branch and the motion branch. We have additional losses to enforce a cross-modal latent space. The motion encoder helps with the convergence of the network and to generate more realistic motion. To summarize, unlike prior works, TEMOS generates multiple motions per text, which can be skeletons or simple bodies. Also, TEMOS does not need an initial frame to generate a motion. Let's see some examples to compare the methods on the test set of the KIT motion language dataset. The projection of the trajectory onto the ground is shown in white. With the text description, a person walks 2 steps, turns around and walks another 2 steps. The leg movements are not well generated by Lin et al. Language to Pose produces a straight line, not following the description. Gauche et al. Follows the semantics, but lack realism. TEMOS is able to generate a realistic and semantically correct motion. Here is another example. With the text description, a human performing a kick with the right foot. Lin et al. Fails to generate the kick. Language to Pose works well here. Gauche et al. Suffer from elongated limbs, and TEMOS works well. To compare with prior work, we performed 2 human studies on Amazon Mechanical Turk. We display 2 motions side by side with a random ordering and ask humans which motion corresponds better to the textual description. Then, to disentangle semantic correspondence and realism, in the second study we ask other workers the question, which motion is more realistic, but this time without showing the text description. Our motions are clearly preferred compared to other methods, both in terms of semantics and realism. For example, TEMOS is preferred 69% of the time for semantic correspondence and 92% of the time for realism compared to the state-of-the-art method of Gauche et al. On the standard quantitative evaluation that compares difference from the ground truth motion, we outperform all previous methods by evaluating one random sample from our generations. In addition, as our method is probabilistic, we can sample more than one motion given a single text. For example, if we sample 10 motions per text and pick the best for evaluation, we are more likely to generate movements that are closer to the ground truth, allowing us to further improve the metrics. Another contribution of this work is to integrate the simple body model in the motion representation, going beyond skeletons. For this, we use correspondences between the KIT motion language dataset and the AMAS dataset. We observe more realistic skeletons, while also allowing to produce body surfaces. Our model generates diverse outputs. Given the sentence "a person jumps forward," TEMOS outputs different types of jumping distances. When the text input is more constrained, as in "a person performs a squat," the diversity is a little lower, but the style and the timing of the generations remain different. Finally, TEMOS has a few failure cases. When we have out-of-distribution textual descriptions, the model often fails to produce the desired motions. As an example, the model fails to generate playing the piano, but generates playing the violin instead. The word piano does not exist in the training set, so playing violin may be the most similar textual description in the training. Moreover, the generations sometimes suffer from foot sliding and can lead to unnatural rotational motion. Code and model are available online. Thank you for your attention.